We'll start in 1 minute. Today we'll be in section 1.3 on fractions. A reminder, if you haven't started in working in Newton yet, make sure that you get your account as soon as possible. If you already have the account, start working. You can complete assignments in Newton late, but you automatically lose 30% by completing assignments late. So it's to your advantage in every way to do the complete the assignments in Newton on time. That way you'll be learning the material on time and you'll get full credit. You might need that extra 30% at the end of the semester. Okay, in section 1.3, this is considered review material. This class, the section P classes, have quite a bit of review material in it, and this is part of that. A fraction is a way to represent parts of a whole. For example, the fraction 3/4 or 3/4 represents 3 of 4 equal parts. We refer to the number on top as the numerator, and the number on the bottom is the denominator. So a graphical illustration of a fraction, suppose we have a circle that is divided into 4 equal parts. My drawing doesn't quite look like it, but just pretend like each one of those 4 parts has an equal area to the other three. So I'll shade one of those quarter circles. So we could say that 3/4 of the circle is unshaded. In other words, out of the 4 equal parts, 3 of them are not shaded. So 3/4 of the circle is not shaded. We could also say that 1/4 of the circle is shaded. Yeah, that's just a graphical illustration of how fractions can be used. We have an equivalence property for fractions. If A, B, and C are numbers where B does not equal 0 and C does not equal 0, then the fraction A over B is equal to the fraction A times C over B times C. Or perhaps more formally, we would say that the two fractions are equivalent, meaning that they represent the same quantity. Fractions that are equivalent to 3/4. Give one example of a fraction that's equivalent to 3/4. There are infinitely many to choose from. Just pick one out of the infinitely many.
$75/100.
Was that?
75/100.
Okay, yeah. If we look at this equivalence property, if we multiply 3/4 by 1 in the form 25 divided by 25, we're all in agreement that 25 divided by 25 equals 1. We're also in agreement that if you multiply something by 1, you get the same value back. So 3/4 times 25 over 25, in the numerator, 3 times 25 is 75. In the denominator, 4 times 25 is 100. So this fraction, 75/100ths, or 75 over 100, is equivalent to 3/4. Another example, if you had -6 over -8, this is a fraction that is equivalent to 3/4 also. To get that, you can just multiply the fraction 3/4 by 1 in the form -2 divided by -2. Well, to write fractions in lowest terms, we're going to use fractions that are equivalent. So here's the definition. A fraction A over B is in lowest terms if the greatest common factor of A and B is 1. So 3/4 is a fraction that's in lowest terms because the greatest common factor of 3 and 4 is 1. Okay, so just in case there's some confusion about what a factor is, when we are referring to integers like 3 and 4, and we want to find the factors or the greatest common factor, we are only considering integer factors. So a factor of a number is a number that can be multiplied by another number to get that number. That might sound confusing, but I'll go into a little bit of detail here. The integer factors of 3, or let's just narrow it down to the positive integer factors of 3. What are the positive integer factors of 3? 1 is a factor of every positive integer, and the only other integer factor of 3 is 3. So 1 and 3 are the only factors of 3, the only positive integer factors. Once again, we refer to them as factors because we can use those numbers and multiply them together to get 3. The integer factors of 4, or more precisely, the positive integer factors of 4. What are the positive integer factors of 4?
1, 2, and 4.
Yeah, 1, 2, and 4. 1 and 4 for sure, but we also have 2. So we can write 1 times 4 equals 4. So 1 and 4 are factors. But we can also write 2 times 2 is 4. And then we only list 2 1s, even though in this product it appears twice. Okay, so when we compare the positive integer factors of 3 with the positive integer factors of 4, there's only one factor that is common to both, and that is 1. And not only is it common, it's the greatest of all common factors. So the greatest common factor of 3 and 4 is 1. And so that means the fraction 3/4 is in lowest terms because the greatest common factor is 1. Lowest terms. Okay, here are some examples of fractions. They're not in lowest terms, but we want to write them in lowest terms. Okay, so we can do an exhaustive approach or a non-exhaustive approach. We want to write this fraction, 210 over 110, in the lowest terms. Well, I'll do an exhaustive approach. So by that I mean I'm going to write down the complete prime factorization of 210 and put those in the numerator, and then the complete prime factorization of 110 in the denominator. So 2 is a prime number. 2 times 210, or sorry, 2 times 105 is equal to 110. And then let's see, when we consider 105, 3 is a factor of 105. Three times 35 is 105. So now we're just left with 35, and 5 times 7 is 35. So in this numerator, we have the prime factorization of 210. Have you encountered prime numbers before, or prime factorizations before? So this is not unfamiliar to you? Okay, then in the denominator we have 110. 2 is a prime number, and 2 is a integer factor of 110. And 2 times 55 is 110. And then when we focus on 55, 55 is 5 times 11, and 5 and 11 are both prime numbers. So this is our prime factorization of 110. And then to get this fraction in lowest terms, we just cancel common factors. 2 divided by 2 is 1, so those cancel each other out. And 5 divided by 5 is 1. Those cancel each other out. So what is that fraction in lowest terms? Yeah, so in the numerator we write 3 times 7 is 21, and in the denominator 11. So 21/11 is the fraction written in lowest terms. But you don't always have to do an exhaustive approach. Learning how to do the exhaustive approach will lend itself to a more or a quicker way to do it. So let's do it a quicker way. If we look at 210 divided by 110, we can notice, well, 210 is 21 times 10. And in the denominator, 110 is 11 times 10. And 10 divided by 10 is 1. So those cancel each other out, and we get 21/11. So that's a little bit quicker to do it that way, and that's perfectly fine. Okay, the next one, negative 30 over 105. So with a little bit of practice, we can write down the complete prime factorizations of both the numerator and denominator. So the numerator 30, the prime factors are 2 times 3 times 5, 2 times 3 times 5, and you can verify 2 times 3 is 6, 6 times 5 is 30, so that checks out. And then 105, well, we already know what that is. What's the prime factorization of 105? So we already encountered 105 earlier. Remember, 2 times 105 is 210. So the prime factorization of 105 is 3 times 5 times 7. And you can always verify. 3 times 5 is 15, and 15 times 7 is 105. Are we all in agreement? Okay, then we cancel common factors. 3 divided by 3 is 1. 5 divided by 5 is 1. And so the fraction written in lowest terms is negative 2/7. Okay, the next example, 42 times x times y divided by 18 times x. So the prime factorization of 42, 2 times 21 is 42, and then for 21, 3 times 7 is 21, and then x times y. Then in the denominator, 18x, 2 is a factor of 18. 2 times 9 is 18, and 9 is 3 times 3. And then we just cancel common factors. 2 divided by 2 is 1, so we get that cancellation. 3 divided by 3 is 1. We also have x divided by x. And so the fraction in lowest terms is 7 times y divided by 3. Okay, so in general, and also when you're working in Newton, when an answer to a problem is a fraction, it needs to be written in lowest terms. On a paper quiz or paper test, I'll be a little bit more lenient about that, but in Newton, it wants fractions in lowest terms. So keep that in mind. Okay, how do we multiply fractions? That's the next topic. Here's a definition on how to multiply fractions. If a, b, c, and d are numbers where b does not equal 0 and d does not equal 0, then if we multiply the fractions a over b times c over d, then the product is a times c over b times d. So another way to describe this, when we multiply two fractions, the numerator of the product is the product of the numerators. And the denominator of the product is the product of the denominators. So when multiplying fractions, just multiply straight across for the numerator and the denominator. Okay, when multiplying fractions, there are usually two ways to go about it. So one way is just to use the definition. So on this one, -3/8 times 4/15. A negative times a positive is a negative. So this is negative 3 times 4 is 12 in the numerator. 8 times 15 is 120 in the denominator. And then write the fraction in lowest terms. So for this one, we can notice that 12 is a factor of itself, and it's also a factor of 120. So we can rewrite 12 as 1 times 12, and the denominator, we can rewrite 120 as 10 times 12. And then 12 divided by 12 is 1. So this simplifies to -1/10. Okay, that's certainly an option, but there is, in my opinion, a more efficient option. So I'll just rewrite this again, -3/8 times 4/15. Before doing any multiplying, look for common factors in the numerator and denominator that cancel each other out. So notice this numerator is 3, and this denominator is 15, which is 3 times 5. And then we have another pair of common factors. This numerator is 4, and this denominator 8 is the same as 2 times 4. So if we write using partial decomposition. I'm going to leave 3 and 4 the same, but I'm going to rewrite 8 as 2 times 4. And I'm going to rewrite 15 as 3 times 5. And the reason I'm doing that is because of the common factors of 3. 3 divided by 3 is 1. And 4 divided by 4 is 1. 1 is a factor of everything, so the numerator still has a factor of 1 in it. And in the denominator, 2 times 5 is 10. So either way, we get negative 1/10. Okay, if we simplify this product of fractions the hard way, well, negative 9/10 times 25/33 is negative 225, because 9 times 25 is 225. And in the denominator, 10 times 33 is 330. And then we have to write this fraction in lowest terms. But with bigger numbers, it's more challenging. But we can do it. So let's see if we can squeeze in the prime factorization. So 225, remember the fraction is negative, but if we just focus on 225, 3 is a factor of 225. 3 times 75 is 225, so 3. Then when we consider 75, 3 is a factor of 75, so 3 times 3. So 9 times 25 is 225, and then 25 is 5 times 5. For 330, 2 is a factor. So 2 times 115. Sorry, I said that wrong. 2 times 165. And then 3 is a factor of 165. 3 times 55. And then 5 is a factor, and then 11. Okay, then we cancel common factors. 3 divided by 3, 5 divided by 5. That looks like everything. So we get negative 3 over 2 times 11 is negative 3 over 22. Okay, so I would advise in general not to go about it using this method. So here's a slight variation on the less exhaustive approach. So we have negative 9 over 10. Write the prime factorization of 9, which is 3 times 3. And then write the prime factorization of 10, which is 2 times 5. And then for the other fraction, do the same thing. 25, the prime factorization is 5 times 5. And this denominator, 33, the prime factorization is 3 times 11. And then look for common factors that cancel. 3 divided by 3, 5 divided by 5. Oh, I see my mistake from the other example. 3 times 5, this should be a 15. Instead of 3. Okay, then in this one, negative 3 times 5 is Negative 15 over 2 times 11 is 22. Yeah, so I made a mistake in that first one by overlooking the factor 5. Okay, let's move on to the next example. So on this one, we have negative 33 over 60 times negative 40 over 88. A negative times a negative is a positive, so I'm just going to ignore the negative symbols. And I'm going to write the prime factorizations of the 2 numerators and the 2 denominators. So 33, the prime factorization is 3 times 11. For 40, for that numerator, well, first think of 40 as 8 times 5, and 8 is 2 times 2 times 2. So the prime factorization of 40 is 2 times 2 times 2 times 5, 8 times 5. Then the denominator 60. So 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. You can verify that 4 times 15 is 60. For 88, 8 times 11 is 88. 8 is 2 times 2 times 2, and then times 11. And then we look for common factors. 11 divided by 11. 2 divided by 2, 2 divided by 2, 2 divided by 2. We have 5 divided by 5. And that looks like all of the cancellations. So in the numerator, we have 3. And in the denominator, 2 times 2 times 3 is 4 times 3, or 12. Wow, I'm really slow today. We had another cancellation, 3 divided by 3. So 3 divided by 12 simplifies to 1/4. So if you are as slow as I am, then you'll notice that I was able to catch my errors or my incompleteness just by I didn't verbally ask myself, but I did notice 3 over 12. Well, that's not in lowest terms. So I went back and looked to see that I had another cancellation. Okay, the next one, 5/6 times 30m. On this one, we can think of this as 5/6 times 30m over 1. And then with some practice, you can develop some shorter methods. So we notice that in the denominator, we have a factor of 6. And in this numerator, 6 is a factor of 30. So we can do this. We can say, well, 6 goes into 6 once, and 6 goes into 30 5 times. So now we just have 5 over 1 times 5m over 1, which is 25m over 1. But anytime the denominator is just 1, we don't need to write it. So we just leave this as 25m. Okay, in this next product, let's use this shortcut method that I alluded to last time. So 5 over 11 times 44 over 5. So we notice this numerator 5 has a factor of 5. This denominator 15 is 3 times 5. So 5 goes into 5 once. 5 goes into 15 3 times. And then look at the other pair of the other denominator and numerator. 11 goes into 11 once and into 44 4 times. So now we're just looking at 1 over 1 times 4 over 3, and that's just 4/3. 4/3 is an example of an improper fraction because the numerator is bigger than the denominator. But that's a perfectly fine answer. Just leave it in that form, the improper fraction form. Okay, the next one, 12/7 times 35/36. So what should we do to find the product that is in lowest terms? Okay, we can notice 7 is a factor of 7 and it's a factor of 35. Also, 12 is a factor of itself and 12 is a factor of 33. Okay, so 12 goes into 12 once. 12 goes into 36 3 times. 7 goes into 7 once, and 7 goes into 35 5 times. So we just have 1 over 1 times 5 over 3, or 5/3 for the simplified product.
Can you do this way with all of these?
What?
Can you do this way with all of these that we just done?
I can't hear you.
Can you do this way with all of these that we just done? Can you write it down?
It's impossible to do it the same way.
I have a hard time. I have a hearing problem.
It's fine. Can you do it this way with all of them that we've just
Oh.
done?
Can you use that same method in all of them? Yeah, pretty much. Yeah, if this is sort of new to you, then I would suggest learning how to do it the exhaustive way, and then you'll naturally sort of see how to take shortcuts. Okay, let's move on to the next page. So this one is on division of fractions, divide fractions. So here's the definition for division. If A, B, C, and D are numbers where B does not equal 0 and C does not equal 0 and D does not equal 0, then A over B divided by C over D is equal to A over B times D over C. So this is indicating that every time you divide one fraction by another, you can convert it to multiplication of two fractions by reciprocating the divisor. The divisor is C over D. It's called the divisor because that's what we're dividing by. So we convert it to multiplication by reciprocating C over D. The reciprocal of C over D is D over C. So do you see what the definition is telling us that we can do? Okay, so if you know how to multiply two fractions, then you're just one step away from knowing how to divide one fraction by another fraction, because you can always convert division into multiplication. Okay, so on this one, 5/18 divided by negative 15/24. The fraction on the left stays the same, 5 divided by 18. We're going to convert to multiplication, but in so doing, we have to write the reciprocal of the divisor. The reciprocal of negative 15/24 is negative 24/15. And now we can use any method that we want to multiply those two fractions. Okay, so the shortcut method, 5 goes into 5 once, 5 goes into 15 3 times. Okay, what about the denominator 18 and the numerator 24? The greatest common factor is 6. So 6 goes into 18 3 times. 6 goes into 24 4 times. Okay, and then don't forget that a positive number times a negative number is a negative number. So this will simplify to negative. In the numerator, 1 times 4 is 4. And in the denominator, 3 times 3 is 9. So negative 4/9 is the result. Okay, the next one, 12x divided by 25 divided by 18y divided by 35. So convert this to multiplication. The fraction on the left stays exactly the same, 12x over 25. We're converting it to multiplication, so we reciprocate the divisor and write 35 over 18y. Okay, one way to go about this is just multiply the two fractions. 12x times 35 is 420x. In the denominator, 25 times 18y is 450y. So how do you like that approach? This one turns out that it wouldn't be so bad, but I'm still going to suggest that we use the shortcut approach. Let's compare 25, the denominator 25 with the numerator 35. The greatest common factor is 5. 5 goes into 25 5 times. 5 goes into 35 7 times. Then compare the factor 12 in this numerator with the factor 18 in this denominator. The greatest common factor is 6. 6 goes into 12 twice, and 6 goes into 18 3 times. So our final answer, 2 times x times 7, don't forget the variable x. The numerator is 14x. And the denominator, 5 times 3 times y, is 15y. We could get the same result from this, but the numbers are bigger, so it might be a little bit more complicated. Okay, for the next 4, I'll just set these up without working through them entirely. So this one, negative 15 divided by negative 5/3. If it helps, you can think of negative 15 as negative 15 over 1, and then convert from division to multiplication. So we multiply by -3/5. And I'll leave the rest of that for you to do. Now you're just multiplying two fractions. But remember that a negative times a negative is a positive. Okay, the next one, -9/16 divided by 33/40. As an intermediate step, we can write this as -9/16 divided by 33/40. And then we can convert it to multiplication. So -9/16 times the reciprocal, which is times 40/33. Okay, I'll leave the rest of that for you to do. The next one, 5/3 divided by 10. So we can rewrite this as 5/3 divided by 10. And if it helps, you can replace 10 with 10/1. So we have 5/3 divided by 10/1. And then we can convert it to multiplication. The fraction on the left stays the same, 5/3. And then multiplied by the reciprocal of 10/1, or 1/10. And so on. Okay, the next one involves a variable. So 3/8 divided by y/12, 3/8 divided by y/12. And then convert it to multiplication. The fraction on the left stays the same, 3/8. And then multiplied by the reciprocal of y/12, which is 12/y. And so on. Okay, we have a few minutes to discuss addition and subtraction of fractions. So here's the definition. If A, B, and C are numbers where C does not equal 0, then A/C plus B/C is equal to A plus B/C. And A/C minus B/C is equal to A minus B/C. So an important thing about adding and subtracting fractions is a common denominator is needed. I can spell a common denominator. When multiplying and dividing, denominators don't have to be the same, but when you're adding and subtracting fractions, the denominators must be the same. So if you're starting out with a sum of fractions where the fractions don't have a common denominator, you have to find equivalent fractions with the same denominator, and then you can add the fractions. So in this one, the two denominators are 12 and 8. So we want to find a common multiple of 12 and 8. So the multiples of 12 are 12 times 1, 12 times 2, 12 times 3, and so on. The multiples of 8 are 8 times 1, 8 times 2, 8 times 3, 8 times 4, and so on. So we see that 24 is a common multiple, right? So we're going to replace the fraction 5/12 with a fraction that has a denominator of 24. But this new fraction has to be equivalent to 5/12. So notice if I multiply 12 by 2, I get 24. So if I multiply 5 by 2, I get 10. So 10 over 24 is equivalent to 5/12. And then I'll show you another way. If we start with the fraction 3/8, and we want to end up with a fraction that has a denominator of 24, well, we can ask, what would I have to multiply this denominator 8 by in order to get 24? 3. So if I multiply by 1 in the form 3 over 3, 3 over 8 times 3 over 3 is 9/24. So I'm going to replace 3 over 8 with 9/24. And now that the two fractions have a common denominator of 24, we can add the fractions. So in the sum, the denominator stays the same, 24, and in the numerator, 10 plus 9 is 19. So 19/24 is the result of adding 5/12 plus 3/8. Okay, in the next pair of fractions, negative 23/27 plus 4/15. Okay, so another way to find a common denominator, write down the prime factorizations of the two denominators. 27 is 3 times 3 times 3. 15 is 3 times 5. And so the least common multiple of 27 and 15 will have all of the factors represented in those two prime factorizations. So the least common multiple has to have 3 factors of 3, 3 times 3 times 3. For 15, 3 has already been accounted for, but the least common multiple has to also have a factor of 5. And then 3 times 3 times 5, 3 times 3 times 3 times 5, 27 times 5 is 135. Okay, so we're out of time. We'll work a little bit more on these tomorrow before moving on to the next section. But if you're online, let's take attendance. Type in your first name followed by your last initial. And I'll take attendance here. Victor Bartley, Sadie Becker, Ammon Coles, Jacqueline Cutlers, Jesse Peck, Bailey Eborn, Sunny Frey, Jennifer Fries, Devlin Hall, Carter Hill, Nicholas Hillman, Alvin Highness, Melissa Jones, Anthony Cole, Michael Montoya, Soraya Claudia, Alec Perrin, Jared Perrin, Richard Van Lees, Noah Redford, Raymond Rudder, Mariah Terrace, Autumn Bactora. Did I call everyone's name? Okay, that's all for today.